All right, so today we are taking one of the most famous equations in all of algebra, and we're going to make it visual. We're going to see how to turn that abstract formula of a quadratic function into its beautiful, predictable graph. We'll show you how to literally see the shape that's hiding inside the numbers. So you've probably stared at this equation before, right? Y equals ax squared plus bx plus c. It can feel, well, a little abstract, just a string of symbols. But what if I told you that this formula creates a very specific, very elegant shape every single time? Our whole goal here is to connect that formula directly to what it looks like on a graph. So let's start with the absolute basics. Before we even think about the numbers or the variables, what's the one thing, the one consistent shape that every single quadratic function makes?
And that's it right there. It's called a parabola. No matter what numbers you use for a, b, or c, the graph will always have this fundamental U shape. Think of it as the equation's unique fingerprint. Understanding this shape, well, that's the foundation for everything we're about to build on top of it.
Okay, so we know the shape is always a U, but that U doesn't always point in the same direction. It can open up towards the sky, or it can open down towards the ground. So the big question is, how do we know which way it's going to go? You know, what's amazing is just how simple this rule is. It all comes down to one single letter, a, that very first coefficient in front of the x squared. If a is a positive number, our parabola opens upward, kind of like a smile. But if a is negative, it flips completely and opens downward, like a frown. It's really just a simple switch that instantly tells you the graph's basic orientation.
Now, besides which way that opens, the parabola has another really key feature that gives it its structure. You see, parabolas aren't just random U-shapes. They are perfectly, beautifully symmetrical.
And this brings us to a super important idea, the axis of symmetry. It's this invisible vertical line that slices right down the middle of the parabola. Everything on the left side of this line is a perfect mirror image of everything on the right.
Here's an easy way to think about it. Imagine you drew a parabola on a piece of paper. If you folded that paper perfectly along this axis of symmetry, the two halves of the curve would line up exactly on top of each other. It's this perfect balance that makes the parabola so predictable.
And that center line? It's not just for looks. It actually holds the single most important point on the entire graph, the vertex. Now, the vertex is either the absolute bottom of the U, its lowest point, or the absolute top, its highest point. And it is always, without a single exception, located right on that axis of symmetry. So if you can find the axis, you've already found the x-coordinate of your vertex.
Okay, this is all great in theory, but how do we find that exact center line just by looking at the equation? Well, for that, we need a tool. We need a specific formula. And that really is the key question, isn't it? It's one thing to see the symmetry in a picture, but to make the picture ourselves, we have to calculate precisely where that line is supposed to go. And luckily for us, algebra gives us a beautifully simple way to do just that.
And here it is. This little thing is the key that unlocks the whole graph. The equation for the axis of symmetry is x equals negative b divided by 2a. All you do is take the b and a values straight from your quadratic equation, plug them into this formula, and boom, it tells you the exact vertical line that acts as the parabola's spine. It's incredibly powerful.
So let's put all these pieces together now. We're not just looking at a random equation anymore. We have a complete toolkit to actually sketch its graph and do it with confidence.
So let's just recap our toolkit step by step. First, you look at A to see if that parabola is going to open up or down. Second, use x equals negative b over 2a to find the dead center line. You know this line is your axis of symmetry. And finally, you know that the most important point, the vertex, is somewhere on that line. You basically have the entire core structure of your graph before you've even plotted a single point. And this is really the main takeaway, isn't it? We started with something that looks like pure algebra, y equals ax squared plus bx plus c, and by understanding just a few key properties, we've turned it into predictable geometry. It's not about memorizing a bunch of points, it's about understanding the structure.
So, we've found the heart of the parabola, right? Its axis of symmetry and its vertex. This gives us its location and its orientation. But believe me, the formula still holds more secrets. It can tell you exactly where the graph crosses the axes or just how wide or narrow that U shape is. So the question I'll leave you with is this. Now that you know how to find a parabola's center, what other secrets can you unlock from its equation?